All right, let's get right into it. Today, we're not talking about coding style, we're talking about survival. Because when you're writing in C for embedded systems, the code that's running pacemakers, cars, and airplanes, your standards aren't just a preference, they're what prevents disaster. So, let's just start with a very simple but very serious question. Would you bet your life on your own code? By the end of this, you'll understand the kind of discipline it takes to confidently say yes to that. So here's our plan. First, we'll get into why C is such a dangerous language. Then we'll introduce the standard that's going to be our survival guide. We'll cover some absolutely critical rules for braces and clarity, see how to make the compiler your best friend, and finally, wrap it up by talking about what it really means to write code you can trust. Okay, let's dive in. Look, C is incredibly powerful. It's efficient and it gets you right down close to the hardware. But it's also old, and frankly, it's just filled with hidden traps for anyone who's not careful. Understanding these dangers, well, that's the first step to writing safer code. The biggest danger, number one with a bullet, is something called undefined behavior. The best way to think of it is like a minefield. The official C language spec basically says if you do this, we guarantee absolutely nothing. Your code might work perfectly for 1,000 hours, and then one day it just crashes a system, all because a compiler update interpreted that ambiguity a little bit differently. And this quote just nails the core issue. The problem isn't some rogue compiler. The problem is baked right into the C standard itself. These gray areas mean that without a super strict, disciplined approach, code that works just fine on one machine can fail catastrophically on another. So if C is a minefield, how in the world do we get through it? Well, we need a map. And that's exactly what the Barr group standard is. It's not a set of rules for making your code look pretty. It's a set of rules for survival. What's so interesting here is the whole philosophy behind it. You need to forget all those debates about where your curly braces should go for aesthetic reasons. This is all about preventing failure in systems where failure is simply not an option. Every single rule in this standard was chosen based on one simple, pragmatic question. Does it help prevent bugs? If a rule could stop more defects than another option, it made the cut. It's a purely practical, defense-first way to write code. Okay, let's get into our first really concrete rule. Now, this might seem trivial, but I promise you, it's been responsible for some of the most infamous bugs in software history. I'm talking about curly braces. Look here. On the left, you've got code that is perfectly legal in C. On the right, you have code that is safe. The danger on the left is that if another programmer comes along later and adds a second line, thinking it's part of the if block, but forgets to add braces, that new line will always execute. This isn't a what if. This is exactly what led to the famous Apple go-to-fail security bug. So here's the crucial point. The Barr group standard makes braces mandatory, always. It has nothing to do with style. It's about eliminating an entire class of sneaky, dangerous bugs that pop up during routine code maintenance. It's a really simple discipline that gives you a powerful guarantee. All right, next up, clarity. Code is read by humans way more often than it's written. And if the next person who has to look at your code can't understand it almost instantly, they're probably going to introduce a bug. The standard forces clarity with some really simple, powerful rules. No cryptic names. Use suffixes like _t, so it's obvious something is a data type. But the most critical rule here is about using fixed width types. Using int is a gamble. Is it 16 bits on this system and 32 on that one? That ambiguity can cause huge problems. But using int 32_t, that's a guarantee. It's 32 bits everywhere, every single time. That simple change gets rid of a massive source of bugs. A good programmer doesn't fight their tools, they use them to their advantage. And your compiler is the single most powerful bug prevention tool you have, but only if you actually listen to what it's telling you. This is the zero warning policy, and it has to be an absolute discipline. A compiler warning isn't a friendly suggestion. It's the compiler screaming at you, hey, I see a potential problem here that you need to fix. Ignoring warnings is like ignoring the check engine light in your car. You just don't do it. And this is exactly why. Every single warning you fix is a potential bug you just prevented, a bug you won't have to spend hours, maybe even days hunting down later on. This isn't about being picky. It's about being efficient and professional. Proactive prevention is always, always cheaper than reactive debugging. So let's bring this all home. These rules about braces, names, and compiler warnings, they aren't just a random collection of best practices. They form a system, a system of discipline, a professional mindset.
And so we come back to this question. Knowing what you know now about all the hidden dangers in C and the discipline it takes to avoid them, how do you feel? The whole point of a coding standard like this is to give you the framework and the confidence to say yes, because you haven't left safety up to chance.
You have to code like lives depend on it, because, as we've just seen, they very often do.